The next section we want to talk about on compound inequalities is absolute value inequalities, because absolute value simply means we're looking for two different types of values. For instance, if we have a plus b, the absolute value of a plus b equals 6, we've done this so that we know that we have to solve for a plus b can equal a negative 6, or a plus b can equal a positive 6. So we already have absolute value automatically sets up two different sets of equations that we're going to have to deal with. So when we deal with inequalities and absolute value, we automatically are looking at two sets of equations that we have to deal with. So let's look at the inequality side of absolute value. For all real numbers, a and b is what? Greater than 0. That means b is a positive number. If absolute value of a is less than b, then negative b, which would be a real negative number, is less than a, and a is less than a positive b. So basically this is saying if the absolute value of a is less than b, then a is between a negative and a positive b. Okay? So if the distance from 0 to a on a number line is less than b, then a has to be between those two. It has to be between these two. Okay? If the absolute value of a is greater than b, then a has to be greater than b, or a has to be less than a negative b. Think about that for a minute. Think about a number line. Let's put 0 there. Okay? Let's say this is b. This is negative b. A is a distance from wherever a is to b. Okay? And we're saying that the distance from 0 to a is greater than b. So what does this say? That means that a has got to be where? That means that a has got to be somewhere out here, right? So a has got to be somewhere there. And then this one right here is saying that a has got to be somewhere over here. Okay? A negative a would have to be over there. So that the distance from 0 to there, okay, so the distance from 0 to here would be greater than b, and the distance from 0 to here would be greater than b. Alright? Can get just a little confusing. Alright, now let's look at the other portion of it. Or let's look at an example of this one. Okay? If 2x plus 1 absolute value is less than 5, then negative 5 is less than 2x plus 1 is less than 5. Okay? If absolute value of 2x plus 1 is greater than 5, then 2x plus 1 is greater than 5, or 2x plus 1 is less than negative 5. Alright? Basically that's simply saying the same thing except with an example in here. If the distance from 0 to this right here, 2x plus 1, is less than 5, then the 2x plus 1 has to be between 5 and negative 5. Again, if the absolute value of 2x plus 1 is bigger than 5, then 2x plus 1 has to be bigger than 5, or it's got to be on the other side of negative 5, because that distance would be greater than. Okay? Let's try an example and see how we go. Alright, go back to black. Absolute value of 3x minus 12 Okay? Alright, so how does this fit in? Okay, we've got 3x minus 12, absolute value of that 3x minus 12 is greater than or equal to 6. So that's going to split up into 3x minus 12 is greater than or equal to 6, or 3x minus 12 is less than or equal to negative 6. Okay? You ready? There's our two inequalities that we need to solve. So let's go for it. We're going to add 12 to both sides. This goes to 0, 3x greater than or equal to 18. Over here, add 12 to both sides. Goes to 0, 3x less than or equal to 6. Okay, we've got a 3x over here. This is multiplication, so we're going to divide. This goes to 1. We're left with x greater than or equal to 6. So over here, the same thing. We've got a 3. It's multiplication. We want to divide. This goes to 1. Leaves us with x less than or equal to 2. Okay, so let's graph. Alright. Put 0 here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Negative 1, negative 2, negative 3, negative 4, negative 5. So let's take this one. Let's use our pink again for our first one. X is greater than or equal to 6. Is this going to be a solid or an open circle? The equal sign's there, so we're going to make that solid. Greater than, it's going to go to the right or left. Greater than, x greater than 6, means it's going to go to the right. Okay, now let's take the other one. X less than equal to 2. Is that going to be an open or a closed circle? It's got an equal sign, so it's going to be a closed circle. Less than, that means we're going to go to the left, so it goes like this. What's the combination of those two? Got a solid circle right there, got a solid circle right there. This is going to the right, this is going to the left. Okay? What's our set notation? X such that x is greater than or equal to 6, or x is less than or equal to 2. That's our set notation. Okay? That's how we deal with solving inequalities of absolute values.